Today we are going to be covering target 2.3a, representing and solving inequalities. First thing I want to do is let's talk about the difference between an equation and inequality. As we've been working with equations, we've been trying our best to find a single number. So ideally there is only one value for an equation. Now sometimes there could be none, there can also be infinitely many. With an inequality, it is representing a range of values, because there's going to be a lot of things that work for an inequality. So again, how many solutions does an equation have? The goal is one, but it could be infinitely many solutions or no solutions. With an inequality, there are possibilities of having no solution, but for the most part, we're always going to have an infinite number of solutions. So let's start analyzing where those come from. To be a solution, as we look at these inequalities here, they just need to be somewhere on this shaded region. So let's look at some of these examples. For which number lines is x equals 6 included in the shaded set? So 6 is part of A, it's part of B, it's not a part of C. With this open hole right here, this is not a solution. It is right here, so that is part of D, and it's also open hole on E, so it's not that one either. So it is A, B, and D, that's it. X equals 4, we're going to see when that one's included. So x equals 4 shows up right here. That is not a part of it, so it's not in A. It is right here, it is a part of this, and it's not any of the other ones. So it's only B and C. X equals 7, we come back here. Shows up in A, and it shows up in E. They're part of those shaded regions. That's what it takes to be a solution. So that's A and E. So which ones show an equality and which one shows an inequality? There is one single equality, and that is D. D is actually showing the equality x equals 6. That's the only solution there. Everything else is an inequality because it has a range of values that work. So we have A, B, C, and E. So this is what it means to be a solution to our inequalities. It has to be within the shaded region. So now let's analyze where the inequality itself comes from. So here's our first example. We have x is greater than or equal to 5. So quickly, let's talk about these symbols. We have greater than or equal to because it has a line underneath. So if it was a less than or equal to, that's also, the line underneath is what makes it or equal to. For comparison, on number 10 here, that one is just less than. So I would say x is less than 5. The biggest difference is whether or not we can include the number 5 as a part of the solution set. So in back to number 9, is 4 a possible solution for x? Yes. Nope, sorry, my bad. No. Because if I test it out, is 4 greater than or equal to 5? It's not. That's why it's not part of it. The next one, is 5 a possible solution? So I'm going to check. Is 5 greater than or equal to 5? Yes, because of the greater than or equal to. Is 6 a possible solution for x? That is yes, because again, 6 is greater than or equal to 5. So how many possible solutions are there for x? There's infinite. There are infinite number of possibilities that are greater than 6. So now when we get to our number line, from what we saw in the previous one, to include the number 5. So the number 5 is right here, right in between 4 and 6. If I want to include the or equal to, it's going to get a nice filled in circle. Since it is greater than, all the numbers that are greater than are off to the right on my number line. with the other possibility, we look at this. Is 4.5 a possible solution for x? Well, is 4.5 less than 5? Yes. Is 5 a possible solution for x? Is 5 less than 5? No. And this is what the big difference. 5 is not included because we are not saying or equal to. We're only saying less than. Is 6 less than 5? No. How many possible solutions there are? There are still an infinite number of solutions. So here's the big difference. When we graph this, not only am I going to the left because it's less than, but I'm also going to put an open circle on 5. This tells us that this is not included. A closed circle is included, an open circle is not. And like I said, it's less than, so it goes off to the left. Here we have a few possibilities. Now, when we look at these, again, the inequality, we're going to rewrite if necessary. Does not apply here, so we'll do that on the next one. Say it in words, x is greater than 5. Quickly graphing it, I'm just going to show right here. Here's 5. Greater than means it's an open circle, and then it's to the right because it's greater than. I'm going to leave you to name a point and check it for yourselves. Instead, I want to go over these other examples. Negative y is less than or equal to 2. One of the ways I can rewrite this is I'm going to add y to both sides, and I'm going to subtract 2 from both sides. So when I rewrite that, it's going to look like 2 less than or equal to y. Well, the other part of rewriting this, to make things a little easier, I don't like writing it with y to the right. So instead, I'm going to rewrite it again and say y is greater than or equal to 2. So if I say 2 is less than or equal to y, that's the same thing as y is greater than or equal to 2. So that is my new term. Y is greater than or equal to 2. On a number line, I would just want the number 2. This gets a closed circle, and it's going off to the right. I want to quickly address the fact that I did not have to add y over to the right side and subtract 2 over here. Oh, I just realized a mistake I made. That was supposed to be a negative 2 then. So negative 2 is less than or equal to y, and y is greater than or equal to negative 2. So the only difference there is that that's going to be a negative 2 on the number line. So that would look like this. It would be a negative 1. This would be a negative 3. So we're going more to the right. Still moving the same direction, but wrong number. As a shortcut, here's what I'm going to show on here. Instead of adding y and subtracting 2, I can change the variables with multiplication and division. So if I have negative y less than or equal to 2, and I divide by a negative 1, so then I get y and I get a negative 2, but if I keep the symbol as is, that's going to be less than or equal to that. That's going to change the direction of my graph. So that means anytime I divide or multiply by a negative number, we need to flip our sign. That is a rule we have to apply, and we saw why we had to do that in our first part of the example. So now we got to make sure anytime we divide or multiply by a negative, we have to change that symbol. It flips. So instead of being less than or equal to, it turns into greater than or equal to. So now we've established that pattern, I'm going to apply that for the next one. So I'm going to divide by negative 1 to make this negative 8 less than a. But since that's negative 8 is less than a, I'm going to rewrite it as a is greater than negative 8. Okay? And again, at this point I'm going to skip writing it in words. I'm going to go right to the number line real quick. So here's negative 8, here's negative 7, here's negative 9. Negative 8 gets an open circle and an arrow to the right. As for my last one, I do not have to worry about negative signs, but again, I'm going to rewrite it so that m is the first thing I read. When I read it from left to right, it says negative 3 is less than or equal to m. When I go right to left, that is m is greater than or equal to negative 3. So here's my number line with a -3. You got -2, -4. That gets a closed circle and goes to the right. We can also work it backwards. Here are my shaded number lines. The first thing I want to identify if I have an open circle or a closed circle. Open circles are less than or greater than. Closed circles are less than or equal to or greater than or equal to. So I know which symbol I'm going to use based on that. The other part of it is where is the shaded region compared to my reference point. So for number 1 here, my reference is number 4. Every number that's shaded is larger than that. So x is greater than 4. On number 2, we have a solid circle at 5, and we have the arrows going to the left. So that is x is less than or equal to 5. I'm going to leave the last 4 examples for you to do and do that as a quick quiz for us. So the last thing we want to talk about today is another connection between inequalities and equalities. So often we will look at an inequality, we need to solve it before graphing. This is still a simple inequality, like x is greater than 3, but we need to transform it a little bit. So in this case, 3x is greater than 12. Well, if it was an equation, we would just undo the operation of multiplication. As an inequality, we're going to do the same exact thing. I'm going to just divide both sides by 3. So that means I get 3x greater than 12, divide by 3, x is greater than 4. Now it's just like we did before. I do not need to rewrite it. I'll let you say it into words, but on a number line, I've got 4. I've got an open circle on that and an arrow to the right. For the next one, a is being divided by 5, so I'm going to undo that through multiplication. So I'm going to multiply by 5 to both sides. A is less than or equal to -20. Again, I do not need to rewrite this. I'm just going to go right to the number line. So here's -20. It gets a closed circle, and since it is less than, it's going to go to the left. The next one, going to be a little bit extra work, but that's okay. So I got 9 is greater than n minus 1. If I add 1 to both sides, I'm going to get 10 greater than n. Well, to make this easier for graphing, I'm going to rewrite it. Because if I read it left to right, it's 10 is greater than n, but that's the same as n is less than 10. So I come to my number line, I've got 10. It is less than, so it gets an open circle to the left. Now we're getting into even more complicated. So this is a very good one to practice our negatives. So just like any equality, and what I've said before, what's the story of m, and then work it backwards. M is being multiplied and then added. So that means I need to undo the addition and undo the multiplication in that order. So -14 less than or equal to -3m plus 4. I'm going to subtract 4 to both sides. So that gives me -18 is less than or equal to -3m. Now, when I divide by a -3, remember, what we showed earlier was if I divide by a negative, I need to switch my inequality symbol. So that is going to be a +6 greater than or equal to m. Well, for rewriting purposes, I'm going to go ahead and switch that order. M is less than or equal to 6. Well, now I can graph that. I have 6. I have a closed circle on that. Less than is going to go off to the left. And I'm going to leave these last 2 examples for you to try out. But remember, just like solving equations, we need to find the order of operations on the variable and then work it backwards. If part of our step is to divide or multiply by a negative number, then make sure you flip your symbol. Rewrite it if necessary, and then you can graph your solution set. And that is our conclusion for 2.3a.